Hello and welcome to our machine learning project presentation. My name is Pierre Antoine MB Focam, and alongside with Michael Fopa Saptala, we work on health related prediction system using real world data. Our project focus on predicting the risk of heart attack using machine learning technique. This presentation is going to be split into two. The first part, I will give a general explanation on what we have done and our conclusion. And the second part, we are going to drill into the data and try to understand the data modeling, the pie chart or the graph, analyze them, and see how we came to the conclusion that we arrived to. Okay, for the first part, our project goal. The goal of this project is to develop a predictive model that can help identify whether a patient is at risk of having a heart attack based on various health and lifestyle indications. Early prediction can significantly improve clinical outcome by allowing early intervention. The dataset. We use dataset from Google, as you can see. We load our dataset from Google, which include medical and demographic information of a patient, such as patient age, sex, gender, cholesterol level, blood pressure, heart rate, diabetes, family history, whether the patient was smoking or not, obesity, and so on. As you can see on our patient data information, which lists all the data that we have been given from our dataset. First, we perform extensive data cleaning. We rename long column names with readability, and we remove irrelevant columns such as country, continent, hemisphere, based on analytic that we are going to drill later on it, as they do not directly influence heart health in medically meaningful way. We also extract useful numerical value from composition column like blood pressure, splitting it into systolic and diastolic for better feature representation. And we analyze which feature were numerical and which were categoric, and we use SketchUp which allow us to choose the information variable. This helps us reduce noise and focus on the attribute with high precision. Now, the reason why we did have to split the features into two group, categorical and numerical, were mainly for in the having for scaling. Numerical data use imputation plus scaling, and categorical data use imputation for encoding. Then we merge them using a column transform in scikit-learn. This helps us to improve model accuracy and interpretability. So it prepared to feature, the feature are comparable, model aren't biased by high variable field, outcome are easy to interpret. And finally, to the conclusion, we build couple of model, and analyze the beta result. The model achieved promising performance, suggesting that which proper data and processing machine learning can be assist in prediction of heart attack risk based on common health indicator. Our project demonstrates how machine learning can contribute meaningfully to healthcare with further clinical validation. Tools like this could support medical professionals in identify at-risk individual before a critical event occurs. Thank you for watching our presentation. We hope you are going to find the second part very helpful. So now we are going to drill into the data. We're going to start with the distribution the distribution plot for numerical feature. So we are going to just drill down the distribution plot for numerical feature, which is here. On this plot, we can see that each numerical variable, like age, for example, cholesterol, is distributed across the dataset. We use scalar density to estimate to visualize the shape of the distribution. So here we have the feature we are normally distributed, which are not influenced by model choice. Now we are going to look and we see that the distribution for each of the feature, whether it is age, cholesterol, symbolic, they have a hard rate. They all follow the same pattern. We see here a normal distribution. The only ifs we have is a bit ratios, where we see that we have a between the age of no, between not the age between 1.5 between 1 and 2 we have the highest propensity going up all the way to the peak at 1.5 and coming down and in biracial rate. Now let's move to the pie chart, which is a categorical feature. Now we see that our pie chart illustrates the distribution of categorical value. Let's take for example male and female. Let's take for example male and female. On the sex part, it shows that, for instance, the proportion of male of data has 69% of male and 30% of female. And we have the data that we are given. We have unhealthy 33 is pretty much split evenly. 33% are unhealthy, 30% have an average health status, and 33% have a healthy status. And we see the distribution of our data based on the continent where they come from. We have in Africa, we have 10%. The lowest property is in North America, and we see that the highest property is Europe. Is Asia and Europe. Now the hemisphere is also split. We have two-thirds are European data, not hemisphere data. Sorry, and one-third, about one-third is southern hemisphere. Okay. Now we did all this plot. You can see, help us analyze for the density on the for sleep rate. We see that, okay, the peak for heart attack propensity is between 10 and 5 and 10, which is here. I would say close to 7. And the peak of the healthy is at 10. We see here we get to 0.17 rate. Okay, so now we have to analyze our heat map to identify the outlier on the heat map. So our heat map matrix shows how strong each feature correlate with other. High correlation between feature can signal a culinary, something that can address we can address during modeling. And we see here the target, and we can sort the correlation toward the target, which is the health attack propensity, from lowest to highest, and that's what we are able to do it here. We have the highest, of course, is target because it's going to be 1, and the lowest correlation or impact in our analysis, you have the sleeping hours, the continent, and alcohol consumption, obesity, hemisphere. And when we start looking at highest population, we have the bite rate, diabetes, systolic, bite definition, and cholesterol. These are the highest propensity for a heart attack. Now, based on this, we were able to start removing, cleaning some data by looking at the column with low correlation. And on this analysis, we see that the income on the income plot, we have like a very low correlation because the income does not affect too much in terms of somebody having a heart attack. We did the pair plotting visualization relationship between all the data to understand the trend, and we look at our trend here in the vertical, in the horizontal vertical axis, and we can see the growth between the data, how the volume keep increasing and shifting to increase toward the heart attack. Okay, so now in terms of running the target, we did, because we compare different type of model to see which one was more related in terms of delivering a better result, and we run different type of model, including a decision tree, naive Bayes, support vector machine, nearest algorithm, logical regression, and in our accuracy chart here, we see that logical regression has a 0.49 accuracy precision in terms of delivering the proper prediction of a person being subject to heart attack. And we see that the nearest algorithm has a 0.47 accuracy rate. And as we go to decision tree, the accuracy jump a little bit higher to 0.5. And naive Bayes is 0.50, is a bit lower. The super vector machine goes a bit higher at 0.54. And as we go on, we see that the Xbox, it goes up to 0.58, give us a much better close accuracy than the previous. So based on our analysis here, we mark them, and we see that the JBoss GMB algorithm is GBM algorithm give us the highest performance with this data set that we have. So in plotting the final result in TwinUp, we believe that the GBM algorithm will be the right way to go. So this is about what we have prepared for this presentation. Again, we did this project together with Michael Fopa-Saptala and I, Pierre Antoine. For any question, please do reach out. Thank you.